Hi, and welcome to the third and final video in our series on taking in parameters and writing some methods with them. So here we're going to demonstrate a bit more how we can get into working with for loops with them. So our first problem is going to be working on the problem we had earlier, right? We had this problem earlier. And let's go ahead and just recreate it. And the idea here was that we wanted to print out 5 lines. The first line had 4 dots in the number, then we had 3 dots, then the number, then 2 dots, then the number, then 1 dot, then no dots. So let's recreate that. Let's call it dots and nums. Okay? So we're going to recreate this first, and then we're going to generalize it out so that we can print this as long as we want. And I'll explain what I mean by that in a bit, but let's recreate this. So first off, we noted that we needed 5 lines, and that the first line starts with 1, then 2, then 3, then 4, then 5. So for int I is equal to, we're starting at 1, so I is less than or equal to, all the way including 5, I plus equals I plus plus. So we go system.out.println, and then I. Print out the value for I. And then we can go over here, print dots and nums. 1, 2, 3, 4, 5. Okay, now we need to actually write inner loops so that we can modify how these dots get printed out. Okay, so the next thing I said to do, the way we were doing this, is that we needed, the way the book suggested it was by creating a table, right? If I is equal to, so let's figure out, the value for I and the number of dots we want. Right? We have I is equal to 1. Let's go ahead and make it so that I can make a table. Okay. So then 1, 2, 3, 4, 5. How many dots do we want now? We want 4 dots, then 3 dots, then 2 dots, then 1, and then no dots. Okay. So then maybe the number, so let's go ahead and start out by writing out that maybe we just get 4 dots in each line. 4 int j is equal to, and we use j for our inner loops all the times, or we can just use dots. 1 dots, the number of dots is less than or equal to 4 dots plus plus. So while dots is less than 4, print out another dot is what we're going to have here. System out.println okay. Oh, our problem here is that we had a print line statement rather than a print. We were printing a new line after every single dot. So now I've got 4, then 3, then 2. So we've got 4 dots, and then we want 3 here, then 2, then 1, then none. So one way to figure that out was by doing the equation, by figuring out by the equation, which is that basically what we want here, we've got 1, we've got 4 here. Then the way we need to get that is by, let's see, we need 5 minus 1, 5 minus 2. And that's kind of the relationship we've got going on here. 3. So we can subtract I there from there. Or we can do, 4, then 5 minus 5 dots. And hopefully that makes sense. We've got 5 minus 8 dots. So we've got this table over here that we've constructed, and then we've got 4 dots, then 3, then 2, then 1. Okay? So now, what else can we figure out? Well, the idea here is that I want to generalize this. Rather than just keeping it to this simple pattern, maybe I'd like to extend it a bit. Maybe I'd like it so that my pattern could be something like this. Three. So hopefully you can kind of see where this is going. 6. Or even something like, 7. So basically, I can make this print out exactly as many as I want. And what I can do is I can print out, maybe I can pass in a parameter. And the idea here is that I want to print out n lines. So if I pass in 5, I'll get this. If I pass in 6, I'm going to get this. And if I pass in 7, I'm going to get this. So the first thing let's do is let's just not worry about the for loop. Let's worry about let's do the same strategy and not worry about the inner for loop. We'll worry about the outer one. And we'll just want to get our 1, 2, 3, 4, 5, 6, 7 numbers printed. So here, that's pretty simple. If I pass in, if n is equal to 5, we do 5 lines, like we have over here. We have 6 lines, we do 6. We have 7, we do 7. So we have n, we do n lines. So now if I pass in 7, let's see what we look like. Where's my error? Oh. Run this. So we've got 1, 2, 3, 4, and then 5, 6, 7. So we've got that. And now here, let's go ahead and I'll just grab this chart to begin with. Alright, so now let's go ahead and fix this up slightly. And we got to engage in some problem solving here. So here, basically, rather than having, what's the difference? Unfortunately, the rightmost column is not going to be very useful to us now. We've got to update everything. So we have 7 lines, but we have 6 dots here rather than 5. Sorry, rather than having 5 and 4. So now we have 7 and 6. 7. We're on the second line, and we have 5 dots, then 4 dots, then 3 dots, then 2 dots, and then on the 6th line we'll have 1 dot, and on the 7th line we'll have 0 dots. So this would be 7 minus 1, 7 minus 2, 7 minus 3, 7 minus 2, 7 minus 3, 7 minus 4. Or we can completely discard this rightmost column and instead think of it a different way, right? This is 6, 5, 4, 3, 2, 1, 0. Okay? So is there any way we can, instead of dealing with like some weird subtraction, that we can just print out, we can get 6, then 5, then 4, then 3, 2, 1. We can write a for loop. Right? We'll keep our for loop, but rather than counting up, we'll count down. So we'll start out with, well, let's go with 6 dots, right? So first we'll just hard-code it in, and then we'll fix it up to be generalized. So I'll start with 6 and subtract, and we want to go all the way down to, so while this is greater than and equals 0, so this will print out. So dots will be 6, 5, 4, 3, 2, 1, and 0. So now if we run this, it prints out 7 dots each time. So now we want 6 dots in the first line, 5 dots in the second, 4, and 3, and 2, and 1. Instead, what we can do is we can print out, we can start I minus, so instead we can say, well, if there's n lines, then the first one has n minus 1 dots, or n minus 2 dots, right? N minus 3, n minus 4, n minus 5. N minus I over here. And this is just to illustrate that we have many different ways about solving this, to go about solving this problem. Oh, got just one too many. We don't need to include 0 there. So we've got 6 dots, then 5, then 4, then 3, then 2. And if I switch this up to be something like 10 now, or if it switch it up to be 25, it extends out pretty well. So let's go and have fun with a problem that I managed to come up with on the train of all places, which is drawing this figurine. Okay. And this one is going to be a bit more fun, I hope. Now this one kind of looks like a snake, so I'm going to call it a snake. And first, let's just work on reproducing this figurine. And I like this because it's a figure where basically we've got this single snake over here. I'm going to call it a snake because it looks like a snake. That doesn't look like it'd be hard to print out, but instead it's made up of a figure that exists on 2 lines, right? It's got the top part and the bottom part. So let's go ahead and try to just make this single line over here. So public static void main print snake. Okay. So the idea here is that I want to print this figure up here. So let's first just digest this figure. Then we'll move up to printing 3, right? Because it's just the same pattern repeated over and over again. So let's just look at this one that I've got highlighted. So it's got a top part and it's got a bottom part. Let's figure out. So here I mentioned that this is one snake and it has a length of 5. And I do that by marking the number of underscores that are in that are on the top part of this snake, right? So the idea here is that basically that when we move on, I'll be able to say a snake of length 2 or a snake of length 5 or a snake of length 7, and we'll know what I'm talking about. But essentially, that each snake, it's just a repeating pattern. Specifically, it's this single underscore, and then this bar underscore bar. And that's basically a single coil for the snake. We notice that this has got 5 underscores over here, and then we have 5 of these on the bottom. So let's see how that works. Oh, we've got a space and 5 of these. And then we've got an underscore and 3 spaces. So let's work on printing out the top of the snake. So 4 int I is equal to 0. I'm sorry, 1, I is less than equal to 5 I plus plus. Okay. So now let's print out the top of the snake. So system.out.print, and we want 5 of these, a underscore followed by 3 spaces. And when we call print snake, it's not going to be anything too exciting. Just a bunch of underscores, right? Followed by spaces. But now we need to do the bottom of the snake. So we'll put a system.out.println so that we can get the next line up and running. So now if we print it out, not only do we get the top part, but now our cursor is positioned right over here, ready to print out. Again, there's 5 segments, so we're going to do another 5 segments over here. And the bottom segment has the pattern space, bar, underscore, bar. So now, that looks pretty good. So now we can write a method that outputs this. Sans this, part where I'm describing it as a snake of length 5 by going public static void print 3 snakes, right? And call print snake 3 times. And this method would print 3 snakes. No. Oh, I would, except what am I missing? I'm missing another print line over here so that we can draw more figures. There we go. We were missing a print line right over here. So the underscore, 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 we're on the same second line. Okay. Got print 3 snakes taken care of. Of course, that's kind of boring. Why should I just have a method that prints 3 snakes? I should have a method that prints any amount of snakes I want. So print so let's go and call it print some snakes. Int number of snakes. Right? So we're going to print number of snakes. So here for int, and that's actually pretty easy to do. Print for int I is equal to 1. I is less than or equal to the number of snakes I plus plus. And now we call each time this loop runs, we just call print snake. And that's just because I changed this, so now call this print some snakes. And now if I pass in 5, it should print out 5 snakes. Pretty cool. Alright. So let's go ahead and modify this further. My second problem is I want to print out these fellas, these friendly fellas, at varying sizes. Let's go ahead. So here, the first snake is length 1. The second snake will be length 2, the third snake will be length 3, and the fourth snake will be length 4, and so on and so forth. Okay? So, obviously I can't change that here. What I can do with print snake is that I can change the length of the snake right now, so I can pass it in as a parameter, right? Print snake int length. And now rather than saying that I want to print a snake of length 5, I can use length over here. Okay, and now if I put 5 here and run this, all the snakes are going to be length 5. Well, I want the first snake to be length 1, the second one to be length 2, the third length to be length 3. Right? And the reason this works is because of the way we thought about it being in segments, right? So if I wanted to print out a bunch of snakes of length 1, it's the top segment, and then you've got the bottom segment. The top part of the segment, the bottom part of the segment. And we're just printing length number of segments. So this method, so what's interesting here and what's different is that this method has a for loop, and it's calling a method, and each iteration of the of this for loop, it's calling a method which has its own for loop, and that's perfectly okay. In fact, it makes it a bit easier to read, right? Because we're printing out an individual snake in this line, and this method over here, this method prints out an individual snake, and this method says let's print a bunch of individual snakes. So how can I alter the length? For the first one to be, I want the first one to be 1 length, the second one to be 2, the third one to be 3, and the fourth one to be 4. Well, I is 1, then I is 2, then I is 3, then I is 4. So that makes perfect sense. So now we run this, print some snakes 5. We'll see that these snakes just keep getting bigger and bigger. Right? So this hopefully will help you getting on the way to solving these problems for your homework. And I'll have some more problems for you to work on Monday. But this is how we can use parameters to basically, create methods that are much more versatile and create code that can be altered and changed much more easily. So I'll see you in lab.